Ladies and gentlemen, please welcome Jason Aspiotis, Director of In-Space Infrastructure and Logistics at Axiom Space, to the stage.
Well, hello. I know we are 1 hour from letting you free from Vegas, so we'll try to keep this one fun for you. As God announced, I'm Jason Aspiotis, Director at Axiom Space for In-Space Infrastructure Logistics, joined by a wonderful group of panelists here. We've got William from Atomos Space, the COO. We got General Butow from DIU, Space Portfolio Director, and CEO of Orbital Composites, Amolak. So I'll give you first some perspectives on what it means for national security in the context of space stations and the overall commercial economy. And a lot of people talk about space as the frontier, and throughout history, frontiers have not been dominated purely through military might, right? They've been dominated by establishing robust and resilient economies in those frontiers, and that's by nations or group of nations. So in a similar way, space and whoever dominates in space will do so through economic might, more so than military might. And a lot of people think about space as, how does it bring benefit back to Earth? But it's also about how do we establish an economy in space for space. And enter Axiom. And our philosophy is, and our CEO is very aspirational when it comes to this, and we all believe it. Our goal is to build a home in space for humans, to grow human presence in space, by 2040 to have 100 or more people living and working in orbital cities, focusing on private and professional astronauts, research development, in space manufacturing for materials to come back to the ground or stay in space. So humans are a critical element to establishing a robust, scalable, and primarily sustainable economy in space, which then gives us as a nation and with our allies the ability to dominate the space domain, the space frontier. And I'll leave you here with this, right? Because the space station we're building is not just about humans. It's just about how do we use the space station as a platform to support the development, demonstration, operationalization of capabilities that are also building blocks this large economic puzzle we're trying to establish in space. So that said, I'll hand it over to William for an introduction, and then some questions around how we think space stations have a role to play in the context of national security for the US and its allies. So, William, go ahead.
Sure. We can go to the next slide. Just skip to the pretty pictures. Very quick introduction. So William Kowalski, co-founder or co-founcer, as it says on the slide there, and COO of Atomos Space. So Atomos is an aerospace startup based in Colorado. We are 36 people. We've raised 2 rounds of funding to date, a little over $26 million, and we are focused on in-space logistics. We are solving this through our orbital transfer vehicles. Our first mission, which you see in the top left there, is going up on Transporter 10 in February. So this is an internally developed mission, primarily vertically integrated. So with a team of 35, we built these 2 spacecraft. It's a $12 million mission, including launch. We did everything from design and build the bus. We wrote the flight software, rendezvous software, picked out the rendezvous package, created the docking interface. We built the avionics stack. I think we built the propulsion feed system. The only things on there that we did not do is the actual thruster head and the solar panels. So a pretty fast-moving team. We are also working on Mission 2 already, so this is the top right slide there. Mission 2 is going to be a GEO fully commercial OTV. adding in a lot more power. It will be a 20 kilowatt system, as well as having robotic arms to be able to capture onto client spacecraft without having to have any bespoke docking interface. So we have a unique system to be able to grab onto light bands and Marmon rings. The last thing I'll mention, so the slide in the center, this is being done under a Phase 2 SpaceWorks contract. We are working with Axiom Space on this, and it is a 5 degree of freedom RPO test bed. Jason, I think you had the pleasure of seeing that just last week, what we've built in-house. We try to be super frugal, very fast. That KUKA arm, which you see on the right, we bought off eBay, and our principal roboticist commissioned it, got it working. For the flooring, we had a special concrete company come in, pour a floor, did a custom polish and leveling to that, and we've built now the air-bearing robot. So the vehicle on the left is a 5 degree of freedom robot simulating our spacecraft. So it has air bearings on the bottom that float on the surface, and then a hemispherical air bearing in the center to give us that 5 degree of freedom, so we can do on-the-ground kinematic testing of our rendezvous suite. So yeah, I'm excited to be here. We're excited to be working with Axiom and talk about space stations and, you know, obviously the importance they play in national security.
Thank you, sir. Bucky?
Well, I just want to reinforce some of the points you made in your introduction. I'm on the stage because I represent national security. National security is more than just our instrument of military power. It's our instruments of technological power, of economic power, and certainly, you know, if you think about, you know, the security for things like even climate, all these things are all aggregate in our list of things that we work on in the national security space. And of course, at the Defense Innovation Unit, our mission is to accelerate the adoption of commercial technology to help solve some of these most difficult problems. If you look at the space station as a destination, as we see it, and all the things that you listed that are, you know, cumulatively for the slide so far, these are all areas that have tremendous interest for us and across the national security spectrum. When I first visited at Axiom, and I spoke to you folks down there, it's like, well, if it was a hotel, you know, hotels have loading docks. And loading docks are purpose-built around vehicles and around special handling equipment. Our experience so far with the International Space Station is that it's a catalyst for innovation. And is a great way to rapidly accelerate the advancement of technologies that retain not just U.S. leadership, but our collective leadership when we work with our allies and partners. So we're very excited about the opportunity. And while we may not have an immediate need for a military space station, most of us, at least those of us from the Air Force, would be more than happy to drop a credit card and spend a night at your luxurious destination.
We'll take you.
On the way to wherever we're going to go in the future. So I'll leave it there.
Thank you. Amolak?
Thanks. Hi, my name is Amolak. I'm co-founder, CEO at Orbital Composites. And Orbital is building autonomous robotic gigafactories for some of the most advanced aerospace and energy products on Earth first. So this includes the next generation unmanned and hypersonic aircraft, as well as energy systems like wind turbines and hydrogen, as well as nuclear. Now, we take the same terrestrial factory and we want to get it space rated and start building large space factories. And very specifically, if we go to the next slide, why is that important for us? We believe it is the single largest step function improvement that you can make since reusable rockets in terms of the cost of building space infrastructure. And that's really, really important because, yes, we have bigger rockets. Yes, we can reuse them, launch them a lot more often, but we still have the tyranny of the launch fairing. There's many things we can do in space if we could just make it over there. So that's a really important concept, and we like to say we are the M in ISAM. We really like to hold on to that very dearly because M is, in our mind, the most critical aspect. And if you do a good job with manufacturing, service and assembly, you get it for free. And the important aspect of why it's important to break that tyranny of the launch fairing is because space represents the only domain where you can start thinking about building global scale energy, transportation, and communication systems. And that represents tremendous economic opportunity, which, as Bucky just said, economic security is national security. So if you look at the next slide, this video was made in 2015, right? So Orbital has actually been on this mission for a very long time. How would you build interplanetary travel rockets directly in space, spaceships directly in space? So what does that mean? You need to be able to make composite aerostructures. You even need to make propulsion systems directly in space. You need to make antennas, pressure vessels. So if you start with that goal, if you keep clicking, it becomes very overwhelming very quickly. So you need to understand what's the first thing we can start with to achieve that goal. And we want to focus on antennas as one of our key applications because the common denominator, we already have a market for big antennas. It's not a new market we need to create. As you go from fixed to unfurlable antennas, the cost becomes nonlinear very quickly. And then you get to the point where you can't make bigger antennas anymore because they cost too much. So we want to make big antennas. It's an existing market. Gives you better Earth observation, better space domain awareness. Our deep space network needs an upgrade, right? There's plenty of reasons. But you also have this massive commercial opportunity with direct-to-cell, and I emphasize broadband because direct-to-cell is happening, but what would it take to go broadband? Actually, it would take lots of antennas, lots of big antennas. And then space-based solar is kind of a whole another level of extreme where you need kilometer-scale antennas, right? So all of these are stepping stones. You could start with an existing market, then there's plenty of national security applications, but also incredible commercial applications. Besides making those things, we're looking at a number of other things. Re-entry shields is very interesting for a lot of the Artemis missions coming up over time. It can be a game changer for NASA. Semiconductors is obviously extremely interesting, doing crystal growth in space. And more exciting things like lunar telescopes, which has been part of science fiction for a long time, but actually a window is opening to perhaps start working towards that. And finally, as I said in the beginning, interplanetary rockets. That was the video made in 2015, and we're still going on that path.
Cool. So good segue, Amolak, about market demand, right? Because the way we see it, as far as growing human population in space, is about growing market demand for in-space logistics, in-space transportation, in-space construction of larger structures to accommodate for said humans. Tell us a little bit more about your perspectives on, human population growth in space. What does that mean from your respective missions? You guys are building OTVs, and from a national security perspective, and then from an space construction perspective, what does it mean to have human population going from, roughly 10 people today to perhaps 20 people by the end of the decade as more stations come online, 30, 40, maybe 100 or more by 2040? So let's start with William.
Sure. So speaking from Atomos's perspective, somewhat selfishly, I think the more people in space, the better, because people need supplies, people need things to live, and that requires quite a bit of logistics, moving stuff around, moving cargo around, and that is the bread and butter of what we do. The bigger the cargo, the farther it has to go, the better it fits into our model. We are purely space resident, in space maneuvering, so looking towards the future where space stations are beyond LEO, that even fits really, really well into what we're doing. The other thing I'll add to that is my personal opinion is engineers tend to be overconfident in what we can solve with robotics and what we can solve remotely and autonomously. And I think for the foreseeable future, there will always be a need to have humans there, humans present to troubleshoot, to figure out issues. Secondly, while I think a person may be passionate about technology or a group of technologies, society as a whole, it's very hard to get society passionate about something that is removed from humanity. So if you look at space and what we do in space, if everything is robotics, if everything is autonomous systems, it is really removed from the human experience. But as you start having space stations going further out, further beyond Earth orbit, and people are there operating, living in this environment, it maintains that wonder and awe and really inspiring people on the ground to continue to develop and continue to push forward.
Yeah, so I think we're on the verge of another industrial revolution in space. Obviously the pivot from large exquisite satellites to small sats, the micro, that was one revolution. More recently to reusable vehicles is another. And now we're kind of seeing this shift to the macro. It's going to be, in relatively short periods of time, our ability to deliver a lot of mass to orbit for relatively inexpensively is important. But just to follow on the topics, the fact that if we're going to save the planet, we have to get off the planet, and there's no time better than the present to start that learning process. And if we're successful, space will be boring. And what I mean by that is, if I could go down to the U.S. Post Office and put a box of Twinkies in the mail, and it shows up at Axiom Station, that we have that. That's at that point we know that the space economy and the terrestrial economy are really one. And your kids will just say, well, yeah, it's just a box of Twinkies, right? So we need to do that and stop treating space as a special thing. There's enormous challenges in implementing this. On the national security side, the trend is that the more commercial space gets, the more affordable space is, and that's very important, because maintaining our technological advantage in space is a great way to deter conflict. And when we do it in collaboration, whether it's in collaboration through government civil programs like Artemis, or commercially, just as part of the global economy, those are really good things. It creates job and prosperity for everyone. So we really strive to reinforce this grand strategy idea that the United States and its allies should be focusing on economic development and human settlement in space. And the economic portion of it is very nascent. Putting humans in space draws a demand signal for routine logistics, for manufacturing in situ on orbit, for all these things that will actually drive this commoditization and the financial investments that are going to make all these early stage efforts worthwhile in the future. And we just want to be part of that journey and help enable it.
Yeah, so I would echo what William was saying earlier about using astronauts and humans or people. I think those terms are going to keep merging more and more. But I think that hybrid approach is very important. There's a lot of examples of industries sort of jumping far into autonomy and then backing off, like the famous Tesla Model 3 assembly line problem, right? Invested $1 billion on robots, but didn't have enough people to actually program the robots, and then went back and built a tent factory. If you look at the autonomous car industry or even the UAM industry, the same thing kind of happened, full autonomy versus partial autonomy, right? From a commercial perspective, sometimes it makes sense to take calculated steps towards the larger goal. And for space, I think astronauts are not going anywhere anytime soon in our mind, because I think they can greatly accelerate what we can do in space. So we need to start thinking about how do we actually make it easier to have more astronauts do more things, rather than think that they're too expensive and my job is to not use them. So because the complexity that they can handle, the unexpected that they can handle, it's very hard to design for that, especially when we start thinking about these very advanced, large-scale manufacturing projects. So we want more and more people up there. These systems feed back on each other. You want jobs for people to go up, do a lot of these different types of missions in space, sort of private astronauts, that helps accelerate the development of commercial and defense applications.
I really like what you said about robots and humans coexisting in a way, right? Because both bring utility and also a feedback loop with each other to warrant both being up there.
Yep.
That's a very good point.
Something I'd add to that, because our business, we write checks to innovative companies. If you came and pitched an idea and said that we're going to do it by having all of our employees work remote, we probably wouldn't sign that check, right? And I really do think it was awesome to hear the numbers of people who are signing up for rides on things like Virgin Galactic and Blue Origin Solutions, because it just shows that humans want to go into space. As I fly a desk now, but as a former Air Force pilot, it warms my heart to know that people are recognizing that machines do have limitations, and we need to move fast. And having worked on the robotics side of NASA in the past, it is non-trivial to do things like even collecting and preparing a sample on a robotic mission is a huge ordeal. For a human, it's easy. You don't even need a PhD to do it. So I think that we need to do this, and if we don't, we'll regret it later, because in a globally competitive world that we're in, others will take advantage of that human-machine interaction.
And others, that's a good segue, right? Because you talked about economic development as a strategic deterrent in space against conflict. Our primary antagonists, China, have a space station, have codified aspirations for lunar base with international partners. So they're certainly looking at it from a long-term perspective with humans in the loop as part of a large economic dominance play. This is lunar and beyond. So we have to do the same, right? Yeah, if not better. Next question will be for specifically William and Amolak. How do you see benefits for your specific benefits, specific to your use cases and capabilities from a orbital transfer vehicle, and then on the in-space robotic construction side? We'll start with William.
Yep. So for us, I think when we first met and started talking, Jason, a number of years ago, was, how could we refuel our spacecraft more cost effectively? And our two biggest operating costs are propellant, specifically getting propellant up to orbit, and then downtime. So our business model is predicated on launch vehicles getting a lot of mass to a single destination and we rendezvous with them and kind of ferry people to where they needed to go. And a space station, in our view, is a great place to go, a great place for those heavy capacity vehicles to drop off cargo. You know, if we're constantly planning, all right, if our vehicle's running out of propellant on this mission, and then we need to plan to put up a refueling pod on maybe this next launch so it can fuel then the mission after that, and then that launch gets delayed. There's a lot of things happening that can really impact the economics of what we're trying to do. But if we have a single point where there's a lot of that excess propellant stored, where we can rendezvous there to both pick up customers and refueling, it really simplifies our model, as well as it makes us way more tactically responsive to national security customers. You know, that is another aspect of that, is being space resident and being able to deploy, say, from a central location if something happens and somebody wants something quickly. We're not in a model where we're stuck in a launch bottleneck and have to get something up there. We're in this central station ready to go whenever needed by commercial or national security customers.
Very good. Amolak?
So from Orbital perspective, there's many reasons that we want to start with LEO stations, and very specifically this idea of ISAM laboratories, right, or laboratory to begin with. There's a lot of reasons why we did not decide to try to build something that is self-sufficient. You know, there's companies that are trying to do that because we think that's short-sighted. There's already incredible amount of money being spent on this infrastructure. It actually makes sense to use it to enhance what you do over the longer period, because this is, you know, this is not a sprint, this is a marathon. You need to think long term. Space station provides a lot of infrastructure, power, comms, astronauts, like we talked about, right? You know, to be able to deal with the unknown. So that's very useful. And you know, Space Force also needs something to protect, right? So if there was a conflict, you know, where they're gonna go, right? You can't go protect every little thing. You protect your prized assets. So it kind of makes sense actually to build that, and that in itself is a form of deterrence. Because people can mess around with little things floating around, but it's hard to ignore when you mess with something big. So anyway, I digress a little bit, but coming back to LEO is a starting point. It's not the final destination. So it allows us to accelerate what we're doing, because ultimately it needs to proliferate into GEO, XGEO, cislunar, and so on. So there's a lot of lessons we need to learn how to make ISAM happen, but then how do we go from an ISAM laboratory to an ISAM factory? So first step is this. Orbital is looking at also working in GEO. So we have a Space Force project where we're working with Axiom for LEO, working with Space Logistics Northrop Grumman for GEO, and then looking to collaborate with Lockheed for cislunar. And the way I think about this is pick the leader in each domain and try to accelerate everything. Don't reinvent the wheel. Focus on piggybacking on the wheel that works and the wheel that's getting a lot of money, and then accelerate that, right? So that's why for us, the Axiom station in LEO is extremely pivotal to accelerate. This is like a nation type of approach, right? We need to think of it as rather than everybody beat everybody down to the ground in one domain, we need to actually look at the bigger picture and fill all these gaps that exist.
And kind of a follow-on question to you, Bucky. You talked about DoD national security apparatus being excited about seeing how commercial space stations come into play in the context of these very pertinent capabilities, national security. Maybe a controversial question, but is there a next step in the future, per your opinion, for dedicated human-rated infrastructure
Well, sure.
for DoD with actual Guardians living and working and doing their operations in space?
Absolutely. So if you, throughout human history, you say, well, what does it mean to be a superpower, right? A superpower, by definition, means that a nation can project power over long distances, or perhaps even globally, and to affect strategic outcomes. And so the way that nations project power is with logistics. And if you look at really at the heart and soul of logistics, there's different models. The one that we look at for space is really a hub and spoke type of model. And if you, in the past, in like the Roman era, you know, they just, the military owned everything because, you know, they owned everything. And so and that didn't work out for them in the long run. But over time, you know, we use commercial methods of transportation, existing global networks and architectures that are augmented with specialized military capabilities that give us the ability to respond rapidly into areas that are not accessible commercially. So, but the hub and spoke model is very important. And you can't just have one hub. You need lots of hubs. So I'm very excited about, I'm not relating, you know, what the commercial and what the civil space is doing to our national security needs, but it's really, really important that we just don't have a single space station and all the logistics are just between it and the terrestrial, economy. We need destinations, multiple destinations to LEO. We need an Artemis gateway, maybe bigger than what it's planned to be, but maybe commercial. Mm-hmm. But we need destinations. Those destinations are, as hubs, are really critical so that in the transportation nodes, like the OTVs and the servicers that operate between them, they provide services. All these things provide the type of commodities that underpin the infrastructure of our expanding economy, and they can be utilized in times of conflict to aid us in power projection, or in doing mass rescue, right? If you have a space station in lunar orbit, it's got 100 people on it, and you have a bad hair day, somebody's got to respond to that. And most of the times it's governments, because we have specialized capabilities to do that. So I think that it's a really good challenge. I also believe that the further you go away from LEO, the more aggregate, it makes sense to have aggregated capabilities. So if you say logistics and fuel and a hotel and all these different things all incorporated in one, much better than having a lot of really small destinations. And so all that works very well. But from a military standpoint, power projection means logistics.
I'll move over to audience questions, and don't be shy, please ask questions through the application. This is a good question. Who should be responsible to secure commercial space stations in orbit from bad actors? I will answer parts of that, then hand it over to all panelists. But you know, there's a spectrum of bad actors and threats that any infrastructure space faces, right? Cyber is one of the biggest ones, the most real ones, and that's something we definitely take seriously. And we actually have programs looking at advanced cybersecurity capabilities, both for the ground and our space station. So let's just say that's something we're looking into and taking care of ourselves, hopefully. But do you want to hand it over to the panelists here to give us your perspectives on, because this touches your capabilities and infrastructure as well, right?
Yep.
So who should be responsible to protecting space stations and directly related infrastructure capabilities?
Yeah, I mean, I do see this would be kind of a guardian role, similar to how the Navy is protecting lines of commerce terrestrially here. You know, this is something we've talked to a few national security customers, because one of the things we're really good at is moving around in space and rendezvousing with things. And we have really optimized our systems for high delta V with high thrust. So very high power electric propulsion system, very high power, eventually scaling into nuclear power systems. And you know, could a system like Atomos be purposed for a national security need to respond, to kind of investigate, to even patrol lanes of commerce, where, say, you have maybe a series of stations from LEO to cislunar to then a lunar environment, and then we are patrolling those areas under the operation of U.S. Space Command.
So one of the things I continue to worry about is debris hitting stuff, small debris, and incidentally, the Soyuz just keep getting hit over and over. And that's I think the stations need to proactively protect themselves. It's just coming to that conclusion, and because there's ways to do damage without, and being able to try to deny the responsibility, right? So I think we need to take that very seriously and just have measures in place to defend against small debris. The large one you can see coming, small one you don't. So, and it's accumulating faster, and the amount of maneuvers you have to do to get out of the way, it's just getting out of control. So there's got to be a solution for that.
I think it's, well, first, I would say we need to extend our terrestrial models out into space. So the first answer I'd say, well, who is jurisdictional authority? So, but we have a long heritage invested in the law of the sea, and which is the commons, and I think it makes a big difference. You know, I'd be curious if the things you're building are be flagged, right? So if you're a flagged vessel, that means a lot. If you want Team America to come and help you out in a time of need, or whoever has responsibility for those vessels under that flag. But I think we need to think about we have human precedent that we've used terrestrially. It would serve us well to start with what we know, and rather than inventing new ways of doing things. But I very much agree with you. You know, in the Wild West, you were the first line of defense, and usually, the cavalry didn't come until the entire village was burning down. And I think space is going to be like that, not just for human-based hazards, but natural hazards like solar flare or anything else like that. We have to have intelligent design to make us survivable in this extreme environment.
Very good. I had a slide before showing some of the use cases of Axiom Station or space station in general in the context of national security pertinent capabilities. We talked about OTVs, recharging, parking, standby, tactical. We talked about using it as a platform for robotics to construct larger structures like solar panels, antennas, etc. Showed a data center residing in a space station using the volume, the power, and the thermal management to support on-orbit data centers in the context of large emerging communications and mesh network. Talked about space debris perhaps being sort of an aggregation depot for accumulating and recycling space debris, and then commodities, storage, distribution, etc. Just your opinion, and please remove bias respectively for OTVs and ISAM, but what are some of your favorite other applications that space stations can support in the context of commercial and national security use cases?
I have to remove bias. So removing bias of what we would use it for, which is really logistics and kind of storage of propellant, I think debris is really the thing that I would love to see. There's the obvious huge hill of legal ramifications of reclaiming debris and how that works, practically speaking, but it is something that will happen and has to happen. We expend a lot of energy, and energy is a lot of money, getting stuff into orbit, getting space-grade metals into orbit, and to just burn them up in the atmosphere or let them float around indefinitely is a huge waste of economic resources, and as we've been discussing, economic resources can equal national security. So we need to find a way to collect all of that and then repurpose it, and with people there to manage that facility is the great way to enable that.
I'll throw some props to our friends at the Space Force, specifically Space Systems Command. We would love to be able to do test and development and evaluation in a true space environment where we have a lot of room to play. You know, space is big, and I think we're rapidly going to be approaching a point where the type of expense we go through to test things on the ground in very constrained environments, it won't make any sense if we can put something on a vehicle and get it to a destination where we can safely do that test and evaluation in a true space domain, because our requirements for that is very much akin to the types of, you know, high vacuum and other things that you could leverage for in-space manufacturing. So for the technology advancement, if we don't have to build it, if we can lease it, or, you know, do co-go and all these other acronyms that we have now, we like to do things that help us to retain our connection to technological relevancy. And so the less we have to put in money-wise into infrastructure, the better we can actually invest in the types of new technologies that solve some of the more enduring problems in space, like the radiation and debris hazards.
So an orbital yard works.
Yeah.
I'm on
it. There's some other ones I could say. Me personally, I like space medicine. You know, do you want to wait on a gurney until the next, you know, dragon comes to take you back to a hospital? No. It's like, you know, hubs are going to be trauma centers in space, right? That's one. And then you and I have talked about this. We need data centers in space. Like, why we need to, like, disconnect from the terrestrial sphere when it comes to collecting, processing, and disseminating information from space. And you know, why not just do it all in situ? And you know, it's a lot easier to distribute it that way, and also the cybersecurity risk is lower. So there, you know, but those are probably my top three.
More to come on data centers. Wink, wink. Amolak.
So to build on the hub and spoke concept, right? So assuming a space station or multiple ones in LEO, and using OTVs to go to GEO, I think using the hub in LEO to aggregate capability, and then being able to, like, in other words, how can we significantly lower the cost of building GEO infrastructure? And I think that's where the LEO station can play a very key role. And that's a combination of everything we're talking about, right? OTVs, LEO destinations. And so this is why, again, back to building that first capability in LEO is so critical, because it's a stepping stone. And just by that first step, we can actually start to do some really interesting things in GEO very quickly, and start, you know, building, again, giant antennas, but it's not just antennas. There's many other things you want to build in GEO, or even service. We have hundreds of satellites sitting around that could use some help. So it will actually accelerate. The missing piece, again, is the M, to close that loop. And because when you go that far, you're hit with surprises. You don't know what you might run into. If you could print what you need once you know what you need, it's kind of a game changer, right? So you use LEO to prove out concepts as an ISAM laboratory. Then you take those learnings and then you start building ISAM factories at GEO, which also has other advantages. They're not that easy to take out versus a LEO factory.
Let's see, we've got 1 minute left, so I'll end with something fun. What's your favorite space station? Babylon 5, Deep Space Nine. Or Axiom.
I'll stick with Axiom for now.
Thank you, so appreciate it. Bucky?
I probably shouldn't say, because if we wind up competing something, somebody will file a complaint. But I'll say commercial space stations is my favorite, whether they're manned or unmanned.
That's a good answer. Are we saying real concepts?
Babylon 5 is a totally valid answer.
What about a Tycho station?
That works too.
Yeah, I'll say Tycho station.
What kind of bar is going to be on an Axiom station?
What kind of what?
What kind of bar is going to be on an Axiom station?
Important questions.
We do have some surprise in our upcoming mission. So.
Oh, you know, there you go.
Well, this has been great, gentlemen. Thank you all for attending. I know we got 15 minutes left until we're free, so yeah, thank you. This has been great.